Have you ever analyzed whether we're truly alone in the universe? Of course, expecting that there's something else to our reality other than whatever we see. Imagine a scenario in which the James Webb Telescope finally reveals that we live inside a black hole. Join us as we explore more about this significant news that will make you question everything you thought you knew about the universe. So, what exactly are black holes? They're like something out of a nightmare. Sure, you might have seen them in science fiction movies, but they're infinitely more terrifying. According to experts, black holes in space are vast amounts of matter compressed into an incredibly small region. Imagine a star, typically larger than the Sun, squeezed into a sphere the size of New York City. The gravitational pull is so immense that nothing, not even light, can escape from it. Researchers have been fascinated by black holes for decades. Since then, they've studied objects in space so massive and dense that they could trap light. The most famous concepts about black holes stem from Einstein's theory of general relativity. Essentially, when a massive star dies, it leaves behind a dense core. If this core's mass is several times that of the Sun, gravity overpowers everything, leading to the creation of a black hole. Identifying black holes is no easy task since they emit no light. However, scientists have found ways to infer their presence by observing their effects on nearby matter. For instance, if a black hole passes through a mass of interstellar matter, it pulls that matter towards it in a process called accretion. Additionally, when a typical star gets too close to a black hole, it can be torn apart, emitting X-rays in the process. Black holes also significantly impact their surroundings. They can consume nearby stars, release powerful radiation, and even influence the formation of new stars in some regions while slowing it down in others. But where do black holes come from? Imagine stars, once massive and luminous, meeting their ultimate demise in a catastrophic event called a supernova. From the remnants of these fallen giants, black holes emerge. Most black holes are born from massive stars that have reached their stellar retirement party in a supernova explosion. Smaller stars, when they die, transform into something called neutron stars, which are incredibly dense but not dense enough to trap light. However, if a star is several times the mass of our Sun, it collapses under its own gravitational force, forming a black hole. As these collapses occur, something strange happens near their surfaces. Time itself begins to behave oddly. From the perspective of someone far away, time appears to slow down near the event horizon, the point of no return for anything falling into a black hole. It's as if the star's clock ticks at a different speed compared to ours. Sometimes, when two smaller black holes collide, they merge to form a much larger and even more formidable black hole. And if a black hole interacts with a neutron star, they create an enormous phenomenon that defies observation. Scientists have been grappling with the size of these massive objects for years. Black holes come in two primary sizes: small and large. There's a sinister mystery surrounding them that we can't quite unravel. However, small is relative when it comes to black holes. Stellar mass black holes, the remnants of massive stars, can be as large as 10 to 20 times the size of the Sun. There may be as many as 10 million to a billion of them in the Milky Way alone. That's a staggering number of black holes that could devour anything in their path. But wait, there's something even larger. Supermassive black holes sit at the far end of the scale, millions if not billions of times greater than the Sun. They exist at the center of giant galaxies, including our own Milky Way. It's like a massive, dark void pulling everything toward it. The renowned physicist Stephen Hawking spent much of his life studying black holes. His lectures were always insightful, though some of his theories couldn't be confirmed due to a lack of advanced equipment. However, there's hope on the horizon. A single scientific instrument is making a tremendous difference, and we're not prepared for its impact. It's called the James Webb Space Telescope, also known as JWST, and it's here to delve into the depths of our universe. Let me tell you, the JWST is no ordinary telescope. It's an engineering marvel and a testament to the power of human ambition. Sure, we've launched other space telescopes before, and they've done their jobs well. But this incredible device is on another level entirely. The JWST makes the Hubble telescope, which has faithfully served us for decades, seem like a mere speck in the universe. And the cost of this cosmic wonder? A staggering $10 billion. Yes, you heard that right. That's enough zeros to make your head spin. It took the combined efforts of NASA, the European Space Agency, and the Canadian Space Agency to bring this marvel to life, along with contributions from over 300 universities. But let's not forget the risks that come with such an ambitious project. This isn't a mission for the faint of heart. The JWST is venturing into uncharted territory, pushing the boundaries of what we know, and taking us to places we've only dreamed of. After a successful launch, NASA recently announced that the telescope has enough fuel to last more than twice its base mission life. Since its launch, the JWST has achieved numerous remarkable milestones. It traveled over 1 million miles to reach its orbit around the Sun, where it will remain indefinitely. During its journey, the telescope successfully deployed its massive 5-layer sunshield and giant primary mirror, both of which had to be folded to fit into the launch vehicle. Now, after NASA has aligned and calibrated it, the telescope is nearly ready for full operation. One of the most fascinating moments of the James Webb Space Telescope's mission was when NASA announced it had captured its first images of starlight. The first image taken by the telescope was of a star. The star captured by the James Webb Space Telescope wasn't just an ordinary star. It was part of a stunning cosmic spectacle that marked the beginning of a new era in astronomy. This image demonstrated the incredible precision of the telescope, showcasing its ability to detect faint and distant objects in the universe. But the JWST isn't just about pretty pictures. It's a powerful tool designed to answer some of the deepest questions about the cosmos. One of the key missions of the JWST is to peer back in time, to the very beginnings of the universe. Using its highly sensitive infrared instruments, the telescope can observe light that has traveled billions of years to reach us. This light, originating from the first stars and galaxies formed after the Big Bang, holds clues about the early universe's composition, structure, and evolution. The JWST's ability to look further back in time than any previous telescope is unmatched, giving scientists an unprecedented window into the birth of the cosmos. Another groundbreaking aspect of the JWST is its ability to study exoplanets, planets that orbit stars outside our solar system. With its advanced spectroscopic capabilities, the telescope can analyze the atmospheres of these distant worlds. By studying the light passing through an exoplanet's atmosphere as it transits in front of its star, the JWST can detect the presence of specific molecules, such as water, carbon dioxide, or even potential signs of life. This revolutionary capability has the potential to answer one of humanity's most profound questions. Are we alone in the universe? The telescope is also set to explore the mysterious nature of dark matter and dark energy, which together make up about 95% of the universe's mass energy content. Despite their significance, we still know very little about these phenomena. By observing the effects of dark matter and dark energy on galaxies and other cosmic structures, the JWST could provide critical insights into their behavior and properties, shedding light on some of the universe's most perplexing enigmas. Furthermore, the JWST will investigate the formation and evolution of stars and galaxies. It will allow scientists to study the processes that create stars, from the collapse of molecular clouds to the intricate mechanisms that govern their growth and eventual death. By observing galaxies in various stages of development, the telescope will help astronomers understand how galaxies like our Milky Way came to be and how they evolve over billions of years. But what about the possibility that we live inside a black hole? Some speculative theories suggest that our universe could be the interior of a massive black hole. These ideas stem from the realization that the mathematics describing black holes is strikingly similar to the equations governing the expanding universe. If this were true, it would completely change our understanding of reality, implying that everything we know, space, time, and matter, might be the result of a singularity's immense gravitational pull. Could the JWST uncover evidence to support such a radical theory? While the telescope isn't explicitly designed for this purpose, its ability to probe extreme environments, such as the regions around supermassive black holes, might provide valuable clues. By studying the behavior of matter and energy near black holes and comparing these observations with theoretical models, scientists might gain insights into the nature of our universe and its possible connection to black holes. In conclusion, the James Webb Space Telescope represents a giant leap forward in humanity's quest to understand the cosmos. From unraveling the mysteries of black holes and dark matter to searching for alien life and exploring the origins of the universe, this incredible instrument promises to expand our horizons in ways we can hardly imagine. As we embark on this new chapter of discovery, one thing is certain: the universe still has many secrets to reveal, and the JWST will be our guide as we continue to seek answers to the ultimate questions about existence, reality, and our place in the cosmos. Called HD 8446, it brought about a mosaic of 18 dispersed brilliant spots from the star's light, caught by the 18 mirror fragments on the primary mirror. NASA later released another stunning image of HD 8446, in which 18 unfocused duplicates of the star were combined into a deliberate hexagonal pattern. Once the observatory successfully aligns the individual segments of the primary mirror, it will begin the image stacking process, combining 18 images into one clear view. Thanks to its cutting-edge technology, the JWST will help researchers study the early stages of the universe after the Big Bang. It will focus on what happened after the first stars formed, a period known as the epoch of reionization. This refers to when neutral hydrogen was reionized, given an electric charge again, by radiation from these first stars. This includes looking back billions of years, a feat possible only with a powerful telescope like the JWST. The telescope will also assist researchers in discovering exoplanets, which are incredibly difficult to detect due to their interactions with their host stars. Its advanced sensors will observe these planets in more detail, including imaging their atmospheres in some cases. Understanding the environments and conditions of these planets could help scientists predict whether certain planets are habitable. Beyond studying planet formation, scientists are exploring galaxies to understand how matter is organized on a large scale. This, in turn, allows us to see how the universe evolved, how the spiral and elliptical galaxies we see today developed from different shapes over billions of years. One of JWST's goals is to look back at the earliest galaxies to better understand that evolution. Researchers are also working to uncover how the variety of galaxies visible today came to be and how galaxies continue to form and evolve. Most importantly, the James Webb Space Telescope aims to answer some of the biggest questions of all. Are we alone in the universe? And are we living inside a black hole? The JWST has already been on the hunt, and guess what it discovered? Structures called polycyclic aromatic hydrocarbons, PAHs, hiding around massive supermassive black holes in 3 active galaxies. These carbon-based molecules with ring-like structures are like the goth children of the universe. They're everywhere, from distant galaxies to comets and even within our solar system. These PAHs are fascinating not just because they could be the building blocks of life, but also because they help astronomers trace star formation. When ultraviolet radiation hits these PAHs, they glow and emit infrared light, a signal that JWST's mid-infrared instrument, MIRI, can detect. This signal typically indicates the presence of hot, young stars nearby. But here's the twist. Astrophysicist Ismael Garcia Bernard from Oxford University investigated 3 active galaxies, NGC 6552, NGC 70319, and the famous Stephan's Quintet, located millions of light-years away in the depths of space. What he found is spine-chilling. In the central regions dominated by black holes, he discovered large amounts of PAHs. Sounds amazing, right? But here's where it gets eerie. The radiation near these supermassive black holes distorted the PAHs, essentially transforming them into larger, electrically neutral versions of themselves. The smaller, electrically charged PAHs disappeared into the void. Imagine being consumed by darkness itself. Yet there's a glimmer of hope. Or is there? The real question isn't whether we are alive but whether we truly exist. Does everything around us exist because of the black hole? Could it be that we're living not just inside a black hole but within the event horizon, the boundary between the known universe and the unknown? The James Webb Space Telescope is out there right now, searching for answers to the mysteries of existence. Stay tuned. Perhaps it will compel us to rethink everything we thought we knew about reality. Reality might be far more twisted than we realize. In the fascinating world of astronomy, few topics generate as much intrigue and mystery as black holes. These cosmic entities, with their ability to bend space-time and consume everything in their vicinity, have long been the subject of both scientific study and popular imagination. The statement, "We finally found what's inside a black hole," made by renowned physicist Michio Kaku, taps into the wonder and curiosity surrounding these enigmatic objects. But what does he mean by this bold claim? Has science finally uncovered the secrets of what exists within the event horizon of a black hole? To understand Kaku's statement, we need to take a step back and explore the concept of black holes, the current state of research, and the significance of recent discoveries in this field.